Clearly, SpaceX's Starship is facing challenges with its heat shield, particularly the heat-dissipating tiles that protect it during reentry. However, with Elon Musk's determined attitude, he certainly won't let this hinder his ambitions. Recently, Elon Musk revealed impressive technical solutions to address the heat shield issue. Let's find out on today's episode of Alpha Tech. How did Elon Musk's SpaceX fix the Starship heat shield in reentry? In engineering, a heat shield is a component designed to protect an object or operator from burning or overheating by dissipating, reflecting, or absorbing heat. Therefore, no spacecraft can re-enter Earth's atmosphere without a heat shield. It is also a crucial component of SpaceX and Elon Musk's ambition of fully reusable rockets. With the impressive performance in the fourth launch, we observed instability with the heat shields, specifically a weak point between the flap and the main body of the Starship. This vulnerability nearly compromised the spacecraft, as the intense heat during the re-entry caused considerable damage to the flap. Despite this, Starship remarkably managed to complete its landing burn with the flap still functioning, demonstrating the spacecraft's robust design and resilience. But not to keep us worried about the issue of heat shields for long, SpaceX and Elon Musk have been striving to improve the heat shield landing capabilities of their reusable Starship. And indeed, they are being carried out right on Ship 30 in preparation for the launch of Starship Flight 5. The first solution proposed by SpaceX and Elon Musk is to replace the entire heat shield with new tiles that are twice as durable as the previous ones. We're going to replace the whole heat shield on the ship, so the new heat shield tile is about twice as strong as the ones that were on the last flight, shared Musk. The new tiles are about twice as strong, or hopefully half as likely to crack or come off. If during the fourth flight, the Starship's heat shield could withstand external temperatures of up to 2,600 degrees Fahrenheit, 1,430 degrees Celsius, which is hot enough to melt aluminum, a metal used in the structure of many launch vehicles, the new heat shield will withstand temperatures of up to 5,200 degrees Fahrenheit, 2,860 degrees Celsius. That is a massive number. This, combined with the heat shield's excellent hexagonal shape without straight lines for hot gases to accelerate through gaps, will enhance its durability against extreme temperatures when re-entering the atmosphere. By addressing the weakness observed in the recent flight, the company is striving to make Starship a more reliable and safer vehicle for future missions, including those carrying human passengers. Next, Elon has revealed that SpaceX plans to add an abrasive layer beneath the heat shield tiles. This new layer is designed to act as a secondary line of defense, providing additional protection in case the main tiles crack or fall off during launch or re-entry. Adding this abrasive material is a strategic move to prevent catastrophic failure and ensure the structural integrity of the spacecraft under extreme conditions. Ablative materials are designed to slowly burn away in a controlled manner when exposed to the intense heat of atmospheric reentry. This ablation process absorbs a tremendous amount of heat energy through the material's phase change. Adding this sacrificial ablative layer underneath the primary heat shield tiles can provide an extra level of thermal protection during the demanding reentry environment Starship will experience when returning from orbit. The ablative material chars and burns away, but in doing so, it insulates and protects the heat shield tiles and vehicle structure from the most extreme heating. Some specifics on the ablative material SpaceX plans to use have not yet been made public. However, Elon Musk has said that this material is like a silicon felt ablative, which is not good for reuse, but keeps the ship and its inhabitants safe in case the tiles fall off during or before re-entry. The addition of this ablative layer aims to increase the overall heat production capabilities of Starship, potentially allowing for higher re-entry speeds and heating conditions that the heat shield tiles alone could withstand reliably over many uses. And surprisingly, Elon Musk has thought of this measure beforehand. He said that SpaceX tested this secondary abrasive material during the fourth flight in areas where the heat shield tiles were deliberately removed. Simple, yet extremely important. There were 2 empty slots without heat shield tiles on Ship 29. So, why did SpaceX take such a risk? Didn't Elon Musk previously warn that missing just one tile would cause the Starship to explode? Yes, it was an experiment. SpaceX eventually stated that these experiments were deliberately conducted to test whether or not a missing tile would indeed be a mission-ending scenario. The location of these tiles is also noteworthy. They are in critical areas such as the ship's engine margins. If the steel did indeed melt, causing any engine-related systems to fail, it would impact the Starship's positioning. Additionally, next to these 2 empty places, there was another tile that appeared thinner than the others. We can also notice this when looking at zoomed images. Of course, this was another test by Starship with a thinner and lighter test shield. The trend of this test focuses on the potential to reduce the overall weight of the spacecraft. This may appear in future prototypes. The possibility that this tile merely appears thinner could be due to the insulation foam layer beneath the tile being removed. This layer lies between the bare stainless steel and the tile to provide insulation during reentry. Moreover, a thinner heat shield also facilitates the integration of the secondary abrasive material into the spacecraft later on. To be honest, this comprehensive redesign of the heat shield is a key component of SpaceX's strategy to achieve rapid reusability for Starship. By increasing the strength and reliability of the heat shield, the company aims to reduce the need for extensive repairs and maintenance between flights. This not only enhances the safety of the spacecraft, especially for missions carrying human passengers, but also aligns with SpaceX's broader goal of making space travel more cost-effective and sustainable. There are certainly many exciting things we are waiting to see for future Starships. However, SpaceX must implement these changes to know their effectiveness. SpaceX has not yet announced the results of the 2 heat shield mini-tests, but we all know that SpaceX is clearly identifying the best way to make modifications. Notably, these new modifications were immediately implemented on Ship 30 for the Starship Flight 5. On June 11th, we saw the first activity of dismantling the heat shields from the nose cone of the spacecraft. In the upcoming days, SpaceX will remove and then reinstall the new heat shield tiles. It's worth looking forward to seeing the results of this change. So, what do you think about this issue? Please comment and let us know your thoughts. By the way, if you haven't subscribed to our channel yet, we humbly ask that you give us a like and subscribe. That's a huge motivation for us to keep putting out more quality videos for you to watch. Indeed, the aforementioned issues with Starship's heat shield need to be put into practice to see how complex they truly are. But did you know that even before the heat shield was tested, it posed many challenges that SpaceX struggled with? The re-entry phase of a spacecraft's journey is one of the most technically challenging aspects, particularly regarding the heat shield's performance. SpaceX's uses of ceramic tiles for Starship's heat shield presents several significant challenges. Ceramics, while excellent at withstanding high temperatures, are inherently brittle. This brittleness makes the tile susceptible to cracking and breaking under the mechanical stresses experienced during launch and re-entry. One of the primary issues with ceramic tiles is their tendency to expand and contract due to temperature changes. During launch, the rocket experiences intense vibrations and mechanical stress, causing the structure to expand and contract. As the spacecraft reaches space and encounters extreme cold followed by the searing heat of re-entry, the ceramic tiles undergo substantial thermal expansion and contraction. Keeping these tiles intact and properly adhere to the spacecraft under these conditions is a formidable engineering challenge. The situation is reminiscent of the Space Shuttle's heat shield, which also used ceramic tiles. The shuttle's tiles required meticulous inspection and often extensive repair after each flight, significantly extending the turnaround time between missions. The repair process was labor-intensive and costly, as each tile had to be carefully checked and replaced if damaged. SpaceX aims to overcome these challenges by not only improving the strength of the tiles, but also by integrating a secondary protective layer of ablative material. This dual-layer approach provides a backup in case of tile failure, absorbing and dissipating heat to prevent catastrophic damage to the spacecraft. By learning from the Space Shuttle's experiences and advancing heat shield technology, SpaceX is working towards a more robust and reusable system. This is crucial for the company's goal of rapid reusability, reducing the needs for extensive post-flight repairs and enabling quicker turnaround times for Starship missions. That's all for today's episode. Thanks so much for checking us out, and we hope to see you next time. Take care. Bye.